So I will talk quickly about Robot Operating System 2 today, just so you can get a quick overview of what it is and how you can use it in your robot projects. So, that works great. So what is Robot Operating System 2? You might, from the name, guess that it's an operating system, but it's not. It's a middleware, and it's basically just a set of software libraries and tools for building robot applications. This is from their documentation. It connects different components. So you might have like a server that is calculating from video data from a robot the surroundings, and you have a robot that is executing on this. Or maybe you have 10 robots in like a football game or a thing like that. And then you want to have multiple components, and you want the components to be able to talk to each other. And what is nice with ROS 2 is that, contrary to ROS 1, it aims to provide real-time capabilities. So if there is any use case for you for a real-time capable system, probably don't use it, but you can try it. It supports different underlying networks, so there are like different middlewares. I will not go over them because that would take too much time. But basically everything from like you have a very stable network setup, maybe even with cables, to like there is a spotty Wi-Fi connection and you need to make sure that it's not using too much data, is possible through different underlying network middlewares. And contrary to ROS 1, ROS 2 supports encryption of communication between components. So it's basically just using some crypto library with keys that you sign, and you can verify which components talk, and you can encrypt the data, and then you can say, okay, this component is only allowed to talk to this other component on this specific topics, that is in 1 second. Okay, so I will go over the basic concepts used in ROS 2, and the first one is a node. I have talked about like different components. What this is in ROS 2, it's basically different nodes, and you can think of a node as a component that is compiled into an executable. This is mostly in C++ or in Python, so with Python you don't really need to compile, but you're still like executing the file. So they run as a separate process, and they connect to the ROS 2 graph. More on this on the next slide. And more or less the basic feature, they can talk to other nodes. So I mentioned the word graph. What is the ROS 2 graph? So basically we can think of discovery as just one node finding other nodes in the local network. So this is in basic scenarios done with like multicast, but you can also have a central server that they connect to. And then you can split them into, if you have multiple ROS instances on the same network, you can also split them into different ROS domains. So each node only sees the nodes in the same ROS domain. So now the nodes advertise themselves periodically, and together they all build the ROS 2 graph. So this is just like the instance of all nodes that talk to each other. How do they talk to each other? They can use topics, services, and actions, and you can combine them. So it's possible that one node subscribes to multiple topics, calls multiple actions and services, or is the server for them. So let's go over them quickly. What is a topic? A topic is basically subscribe and publish, like you would have with MQTT or something like that. So they are asynchronous. So the first node is not blocked by the second node working through the topic, and they don't have like a root back. So in like synchronous programming, you call a function, it responds. In asynchronous programming, you write, in this case, to a topic, and a different node or multiple different nodes work through the message queues, but they don't directly respond to you. They can respond over a second topic, but this is not like a direct connection. So, yes. And what this also makes possible is that like one node can publish a lot of things to the topic, and the second one needs a bit more time to work through them, so it can buffer these messages and work through them one after the other. And you can have unlimited publishers and unlimited subscribers. I have this graphic from the documentation. So you have two nodes. The upper node is publishing a message to the topic, and it flows then to the bottom node. This can also be the case with like multiple nodes publishing and multiple nodes subscribing to the topic. Okay, so if we now want to have something synchronous, we can use services. They are call and response, so it's more like a function in a programming language. In this case, you can have multiple clients calling these functions, the servers, but can only have one server that answers the requests. And now I already said the word answer, so it's possible to like send a request payload, but also get a response payload. But one node can communicate with multiple services. And one specialty with services in ROS2 is that they should only be used if the server responds very quickly. So like in a few milliseconds. Don't do something like a big computation, but it's more like, okay, say, give me like your rotation. How are you rotated? I need this now. So I also have the graphic from the documentation, and there you can see like the lower node requests it goes to the upper node, it works through the request and responds through the same service. So I said that services are for quick tasks, and they're actions for long-running processes. Here the same thing applies. You can have multiple clients but only one server. But the nodes can still communicate with multiple actions. And under the hood, this consists of topics and services that are pushed together. Also brought this a bit more complicated diagram from the documentation, but it's basically you set a goal. This would be like, okay, I need the robot to turn 90 degrees, and then you can get feedback continuously, like, okay, I've already turned 5 degrees, and at the end it says, okay, I'm done. They also have the advantage that you can cancel them, so you can say, okay, no, now I need a different goal, please turn 5 degrees back. So this is the basic concept. If you now want to start using ROS, you have an easier time if you use some tools they provide to you. This one is RQT Graph. So I've talked about like how the graph is built, but you might want to see it visually. If you have a lot of nodes, it might be easier to look at it than to read through your source code. Now you see I have 3 nodes there, and the nodes each communicate through one topic, and you see how they are connected in the graph. There's RQT console. This is useful because ROS2 has a built-in logging functionality, and each node can log, but you can look at the log centrally, and you can filter through it with RQT console, and you can filter by severity, and you can say, okay, like now I want to highlight a certain message, like I did at the bottom with the word transmitting. If you want to look at what your robot did later on, maybe it like ran into a wall and you think, okay, that shouldn't happen. What happened there? There's the tool back, which basically provides you the ability to record topics, services, and actions, and crucially to play them back, so you can see exactly what happened and like replay that. You can launch this either as a standalone tool and just say, okay, record this node, record all nodes, or you can even build this directly into a node. If this like is production critical, you might want to have this running all the time. And now if you have a lot of nodes, like I had 3 nodes in the RQT graph, you don't always want to launch them one by one, because then like if you follow their documentation, you like have 5 open consoles on your Ubuntu 22 VM or something like that. You might not want to do that, and then you can use launch files that just launch multiple nodes simultaneously, and they can configure the settings of the nodes, because otherwise you might end up with really long comments to start it. They can be implemented in XML. They can also be implemented in Python. If there are like a lot more complicated options to set, you cannot do everything in XML. So in this case, I start one node 2 times, and I start the other 2 nodes. And you can also see the commented out option remap. This would be an option that I can set where I can say, okay, the nodes still think it's publishing to this old topic, but I want to have it published to a different topic. This might be like interesting if you reuse nodes from other implementations. So I've talked a lot about nodes, but not really how you implement them. This is possible in C++ and in Python, and there are community add-ons for other languages as well. I've brought with me a small Python example. In this case, you see a node that just subscribes to one topic and publishes to a different topic. And it's not a lot of code, because all the heavy lifting, so the communication with like the backend that talks to the other nodes is abstracted away, and you just say, okay, call this function if you received a new message on this topic, and you say, okay, publish this message to the topic, and there's a bit of logging, like, okay, I will now log a debug message, I will log an info message, and things like that. So, in summary, ROS2 is a middleware for robotic systems, but you can use it for all kinds of systems. There might be some use cases where it's better than running your own MQTT server or something like that. A node is basically only a component in a ROS2 graph and is a running process. They can communicate over topic, services, and actions. The topics are publish and subscribe based, and services and actions are call and response based, with services being for short processes and actions being for long processes. Thank you. Are there any questions?
I suspected the components that have real-time requirements. Are there any elements of real-time programming? Are there any elements of real-time programming in the framework, making use of real-time calls of Linux or something?
I know that. So with ROS1, this was basically impossible. With ROS2, they aim to support it. I don't know how it works in the background and how exactly they do support it. I know that there are some problems with it, but it's possible, and there are like companies building it on their real-time capabilities. So it does theoretically work, but I don't know exactly how.
Thanks, Strifel, for your talk.